Welcome to our day 4 here on Polar. This one is really basically a review. Maybe a little new stuff thrown in here and there. It's really just going to be like a free response type of question for Polar. So we're talking about arc length a little bit along with area. So we've discussed some of that already. So just one prompt here for this, and then it's just a couple pages of it. All right. So let's go ahead and get through. So we have a curve is drawn on the xy plane described by the equation in polar coordinates. R equals 2 plus sine 2 theta, and we're only going this from 0 to pi. What r is measured in meters? And so that's good to know. R is in meters, and then theta is measured in radians, like it usually is. We're going to go ahead and sketch this curve. That's the first part. So I'm going to do that in green. Okay, so for sketching this, I'm moving my sinusoidal axis up 2. So we're up here at 2, there's 1, and there's 3. And then since this is 2 theta, I'm actually going to end up changing this up a little bit with how I would sketch this. And by the way, this is graphing calculator, so I'll go ahead and show you how to graph this in the calculator as well, because this is just kind of like a weirder problem. I wouldn't ask you to do this one by hand, but I just want to show you. Can you get a little practice for this? So sine 2 theta, that period is going to bring me out here to pi. So we're going to get pi over 2. We're going to get pi over 4. And this is going to be 3 pi over 4. Okay, so it's going to look something like this here, 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 and here. Okay, so out here at 0, we're at 2. And at pi over 4, which is this line right here, we're at 3. So do your best here. So like we're going to be out here a little bit, about there-ish. Pi over 2, we're back at 2. And at 3 pi over 4, we're at 1. So it's again in this direction. So we're about like right here-ish. And then at pi, we're out at 2. So this looks like a weird one, not like a nice fun little shape here. So it looks like we're doing something along the lines of this. All right, looks kind of weird here, but something along those lines. So let's go ahead and double check with the old calculator. All right, so to go ahead and graph this, by the way, make sure we're in the correct mode. So there is function mode, there's parametric mode, and there's polar mode. Guess what mode we're going to click on? We're going to click on the polar. So now we hit y equals, it changes into these r's. Okay, so we're going to get 2 plus, let me go ahead and focus this a little more, see it better. 2 plus sine of 2 theta. Now when you hit this button right here, it's going to change. Instead of x, it's going to read it as theta. Because if you notice, that button says x, t, theta, n. And the reason it says that is when you go to mode, function is x, parametric is t, polar is theta, sequences are n. So just kind of giving you a FYI on that one. Okay. And then I believe if I just hit graph, it should just graph the standard thing, right? Yep, there we go. Beautiful. So I'm only graphing from 0 to pi, though. So if I go to window, this theta max and theta min, it's at 0, but this one should just be at pi. So I graph it, and that kind of looks like what I did. So yay, that worked. Awesome. Okay, so that's for graphing it. And honestly, if I'm not graphing, I'm going to want to get out of this mode. So I'm just graphing it just to see. I know there's other questions that ask us other stuff. I just want to get out of this mode because sometimes weird things can happen if you're not in function mode. So I'm going to go back into function mode so that I can do the rest of this problem. Okay, so here we go. So find the area of the curve. This one's not a big deal. We're just going to do our user formula here. It's 1/2 from, it says from 0 to pi, which is super nice, of 2 plus sine 2 theta squared d theta. So all you're going to do is just type that into your calculator, and I'll go ahead and do that with you right now. Again, I'm back in function mode. Whoopsies. So the world is good here. And actually, I'm going to just double check, make sure I'm in radio mode, because I share this calculator with other people. Oh, and I forgot my 1/2. Let's put a 0.5 in front. And then 2 plus sine 2 theta. Make sure we square all of that, theta, and we should be getting an answer of like 7 something. Yep, so this is going to be 7.0685. You can truncate it, whatever. I like truncating things, so I'll just leave it at that. Arc length. So arc length, we have this formula up here to tell us what arc length is. There's the formula, little star. So stuff that you got to memorize here. Okay, so we're going to go ahead and find that out just by plugging everything in. So we're going to go from 0 to pi, square root of r. So r is this guy right here. So it's going to be 2 plus sine 2 theta all squared plus dr d theta. So we're going to need to do just a little bit of math here. Dr d theta is going to be equal to, 2 is going to be 0. So we're going to have 2 cosine of 2 theta. Okay, chain rule, take the inside first. So we're going to do that squared. So 2 cosine 2 theta. It's going to be all squared d theta. So there you go. Just to save time, I showed you how to type in the calculator earlier. You would just type this in the calculator and you get an answer of an arc length of 7.701. I think it's 18. I'll just truncate it. Not a big deal here. All right, we're moving along. So find the angle that corresponds to the point on the curve at -1. So now we're converting. So we need this formula right here. X is equal to r cosine of theta. Because we're trying to find the x coordinate that coordinates to -1. So at -1 equal r. What is r? R is this guy right here. 2 plus sine 2 theta times cosine theta. And I have a calculator, so I'm just go ahead and solve for this because otherwise this would get really ugly. And get ugly fast. So to solve for this, I'll just type into y1, y2. So y1 is -1, y2 is going to be this 2 plus sine 2 theta times cosine theta. And again, I have this back in function mode because I'm familiar with finding these intersections in function mode. Zoom 6 and just sees where this intersects. It's going to intersect, it looks like a couple of times here. But again, I'm just between 0 and pi, so I only want to find the intersection between 0 and pi. Pi is like 3.14, so 1, 2, 3. So it's going to be about right there. So intersect. So make sure you go over to where the intersection is because there's a bunch of them. Calculator's going to go to the closest one that your little ticker dude is at. So first curve is blue, second curve is red. That's about the estimate. And I'm going to get a theta value of 2.630. And so when x is -1, theta is at 2.630. So that's like right here-ish on my graph, which makes about sense because we're not quite at pi, but we're almost at pi type of deal. All right. First page, not a big deal. Just formulas you need to memorize. And we get to be a little bit of a big deal now. This can get a little bit confusing. So let's go ahead and go right through it. So find the value of dr d theta at the instant that theta equals 5 pi over 7. That's not the hard part. Here's the hard part. Tell us, what does your answer tell you about r? What does it tell you about the curve? So all we're going to do here is just find dr d theta at this value right here. So what I'm going to do is I'm going to try to outsmart the system here, go back to my y1, y2, and just type in my r so that I don't have to solve for dr d theta, just in case I made any boo-boos earlier, because it's a free response. So this is 2 plus sine of 2 theta. This is the original prompt. Okay, so that's the original curve. And then now I'm going to go to the derivative of y1, because I just typed it in, at 5 pi over 7. And this is going to give me an answer of, so dr d theta at 5 pi over 7 is equal to -0.445. All right. So what does that tell us? Well, that at this value right here, 5 pi over 7, we're decreasing. So the radius is decreasing. The radius is getting closer and closer to the origin. Okay, so since dr d theta is negative, r is decreasing. All right, so I'm writing this one a little bit wordier than I usually do, just because it's part of your notes. I would just say that, let's tell you about r, that r is decreasing because the derivative is negative. That's all I need to say. Let's tell you about the curve. So the actual curve here, that r is getting closer to the origin, and that's really all you need to say. So at theta equals 5 pi over 7, the curve is getting closer. I think that works. Getting closer to the origin. Okay. So what the heck does that mean? So where's 5 pi over 7? 5 pi over 7 is about here-ish. All right, give or take, somewhere in here. And then, so if you notice that the radius is decreasing here, okay, so it's decreasing. If you notice here, that's getting closer and closer to the origin, and then it starts to increase a little bit afterwards. Last part here, and I'm going to wrap this one up in a nice little bow. We got a particle moving along a polar curve, the same prompt really. So that position is x of t, y of t, such that d theta dt is 3. Find the value of dx dt at the instant that theta is equal to pi over 6. Interpret the meaning, the context, and the problem. So what we really have to do here is finding just d theta dt. So we got to find dx dt, dy dt. So, well, what is x in terms of t? Well, we already did the x value, right? So we know x is equal to r cosine. So x is equal to r cosine. So this is going to be 2 plus sine 2. Am I using t here? No, I'm still using theta. Still using theta, cosine of theta. And then so y is going to be r sine theta. So this is going to be 2 plus sine 2 theta sine theta. Okay? So I have these two things. Did I really need dy dt? I'm just thinking about this one real quick. Oh, it gives me that d theta dt is 3, so find the value. Oh, see, silly me. I actually read the problem. I just need to find dx dt, so I can kind of ignore y. Didn't need to do that. A little extra work there. I thought I did because of that, so if I could actually read. So I need to find dx dt, so I got to take the derivative of this at the instant that theta is pi over 6. And what does that mean? So honestly, I'm doing the exact same thing that I did here. But this time I'm doing this at pi over 6 because I have a calculator in my hand. So this is equal to pi over 6, it says. And this should give me, you can... Yeah, I didn't think this was going to give me what I wanted. Why is it not giving me what I wanted here? Oh, I know why. Because this is implicit. So ignore what I just did. This is implicit because I want dx dt and I have thetas. So that's a bummer. By the way, this is going to be 2 cosine theta plus sine 2 theta times cosine theta. All right, so finding that didn't help me at all. I was wondering if I could just type that in. But I guess not, because this is implicit. So this is why I have to go through and do this one out by hand. Like, I was wondering why. I was like, that was going to be a little too easy. So this is implicit. So let's go through this now implicitly. So here's x. So dx with respect to t, not respect to theta. So what I did in the calculator here, just to show you why it's not going to work that way, that was with respect to theta, the original theta value that I typed in. So that's why this is not going to work. I keep getting rid of it. It's not going to work because that's with respect to theta. So I need this respect to t. So I need to go ahead and do this implicitly. So I'm going to get 2 cosine theta, which is going to turn into negative 2 sine theta d theta dt. plus, and this is going to be a little bit of product rule here. So I'm going to go ahead and get, let's do the first one first. So 2 cosine 2 theta times cosine theta plus the second, now it's going to turn into a negative. So sine 2 theta times negative cosine theta. And from here, I can just plug in a pi over 6. All right, so what I'm going to do here is just plug in a pi over 6. So I'm just going to save you the trouble. Again, I don't want this video to be way too long. Sorry if that was out of focus there. I didn't know if that was on the screen or not. Instead of just going through and plugging this all in for you, I'm just going to tell you what this answer is. And by the way, for d theta dt, you would just plug in a 3. Oh, and I forgot to tag the d theta dt here. So when you do this one over here, this is all with respect to d theta dt. It's going to mix up the answer a little bit. So I took product rule, all this with respect to d theta dt here. So when you plug everything in, you should get a negative 1.7009. Okay, you can truncate it to negative 1.7, and that's totally cool by me. So this was an implicit problem, just kind of running it back through it. I didn't need y. Don't really want to write that down. You're just going to find x. This is x right here implicitly, and then plug in a pi over 6, and that's really it. Interpret the meaning of your answer in the context of the problem. So really what's going on at pi over 6. So at pi over 6, something is decreasing, all right? So the curve's horizontal, so x is horizontal, right? So horizontally at pi over 6, we're decreasing. That's all it means. It's just horizontally at pi over 6, we are decreasing. Okay? So at pi over 6, or at theta equals pi over 6, rather. I can't even spell at. Rough morning. At theta equals pi over 6, the horizontal rate, can you spell rate? Rate of change is negative. And that's really all you need here. So at pi over 6, the horizontal rate of change is negative, or you could say that the horizontal position is decreasing. That's fine as well. So that's what that means for that final part. So sorry about my little couple of boo-boos here. Forget about the implicit. And yeah, so other than that, hey, that's going to wrap it up for this video. And pretty much this is just a free response you can see for polar.